here to present my Kaggle's GenAI intensive courses Capstone project. Uh, it is called Expat Tax and Navigator. The idea is to simplify international tax compliance with using Gemini. Uh, as a challenge that I face as a US citizen living in India is it's challenging to navigate tax obligation across both the countries. The process is often overwhelming due to dense technical treaty language that's difficult to interpret. For example, we have a 43-page long treaty document, and the language is not very human, not very friendly enough for a layman to understand. There are conflicting information from various sources, may it be online or offline. Uncertainty about which country gets to tax which income, and also expensive professional help isn't always accessible, and they are also busy with, especially during tax. Uh, when it's time to file taxes, they are busy with other with the workload. So getting answers to the questions is sometimes challenging. Um, these pain points inspired me to work on this project. The goal is simple: help US expats understand their tax responsibilities in India and US. Currently, the focus is only India. Extract and explain key clauses for US India tax treaties in plain language, provide accurate context aware responses to various tax questions, and most importantly, reduce compliance anxiety through accessible tax information. GenAI capabilities demonstrated here are document understanding, few shot prompting, retrieval augmented generation, popularly called RAG, structured output. So let's see all of these in action. But first, we will get to the explanation for this. So for the document understanding plus few short uh, prompting for data extraction use case, uh, Gemini analyzes the 3D document, analyzes clauses from the 3D documents, and then has a, like based on the few shot prompt that we have that the user has given, it will generate a JSON output. Why JSON output is because it's mentioned in the few shot prompt. uh, the code for this is here. This is the code for it, and this is how the output looks like. Because we have specifically mentioned it should be JSON, that's why we're getting a JSON output. uh, So next is a retrieval augmented generation. The idea is whenever there's a user query, RAG will be used to get a response. Uh, Under the hood, how RAG works is uh, during the retrieval stage, uh, the model parses like the model parses the PDF document, identifies relevant sections, and enables targeted context retrieval. In the augmented stage, there's a load embedding model. Uh, uh, After that, it gathers text to embed the model, and then we the model there are create like vector representations based on the created embeddings. At the generation stage, it will encode the query that the user gives at the beginning. It will perform a cosine similarity search and get top three uh, articles, and then format the result. And based on that, we'll get uh, it will format the result and generate a response. Uh, so next is structured. So yeah, uh, for RAG, this is the code, uh, and this is how the output looks like. These are the three documents. One, the articles that are closest to the So the query here is foreign earned income, and these are the three closest articles related to the user query. In the case of structured planning output, the goal is to show how GenAI can return machine readable data and enable downstream use cases such as filtering, rendering in apps, or storing in databases. For this, the code looks something like this, and the output something like this. Uh, yeah, that's